In this video, we're going to look at two examples of writing equations from context-based word problems and then solving the system that they create. So in both of these examples, we're going to be looking for two things, and we're going to be given enough information, enough context to write down two equations, giving us a system of two variables like we've been working with. So first thing to do with these problems is read them from beginning to end. Don't just read part of it and try and start. Actually read the entire thing, and your goal is to understand what you're trying to find by the time you're done reading. So what are we trying to find? Well, we're trying to find the price of a senior citizen ticket, and we're also trying to find the price of a child ticket. And guys, you know what? Those become our variables. So let's let X be the price of child ticket, and Y will equal the price of senior ticket. And when you're doing these problems, define the variables. Do what I did here. Write down what the variables mean. The thing that a lot of students lack with these word problems is they don't really bother to think about what the variables mean when they're writing equations. And by writing this part down, it forces you to acknowledge what X and Y are. So what do we do now? We have to look for totals in the problem. And we see a couple of places where there are totals. We have a total of $38. We have a total of $52. So totals clue us into what we should set our equations equal to. So something's going to equal 38 and something's going to equal 52. But what? Well, let's look at the information that goes with these. We have 3 senior citizen tickets and 1 child ticket being sold to give us the $38. And if you think about how you determine the total amount of money that comes in from selling tickets, it's the price of a ticket times how many were sold. So we have this linear combination of 3 senior citizen tickets, so 3Y, and 1 child ticket, plus 1X. And for the $52, we have a combination of 3 senior tickets and 2 child tickets. And now we have a system of equations. We have 2 equations, 2 unknowns. Now you have to decide how you're going to solve this. For me, I'm going to choose to get rid of the y's. I'm going to use elimination. And to do elimination, I'm actually just going to subtract the 2 equations because I have 3y and 3y. If I subtract those 2 things, I have nothing. So the y's go away. We're left with negative 1x equals negative 14. Divide by negative 1. And x is 14. And then we substitute that back into one of our equations. So 38 equals 3y plus 14. Subtract 14. 3y is 24, and y equals 8. And this might be where you want to stop, but guys, you can't stop yet because we haven't answered the question. In these kind of questions, we're starting with English language problems, and we are translating them into this math language so that we can do our mathy algebra work to come up with the solution. But then we have to go back and remember that we started in this English language. We didn't have X and Y. So what we need to finish with is we need to actually answer the question. So to answer the question, we say that a child ticket is $14, and senior ticket is $8. You have to make sure that you answer every question appropriately with appropriate units and within the appropriate context. Second example. So again, read the problem and decide what it is that we're looking for and assign those to be our variables. So let's have x be the boat speed. and y can be the current speed. And in this problem, it's important to understand how a boat on a river works. If you're going the same direction as the water speeds you up on the way downstream, it's called. When you're coming upstream, that is going in a direction that's opposite to the water, the current speed, the water speed, is slowing you down compared to what you would be going in still water. So what are the totals we have here? Well, we have total time. We have 10 hours and we have 70 hours, but x and y have to do with speeds, not time. So how can we deal with that? Well, we know it takes 210 miles to go downstream and to come back, and we know the times that it takes each of them. So we could actually find the speed that we're traveling downstream and the speed that we're traveling upstream. So the speed upstream will be 210 divided by 70 hours, which is 3 miles per hour. And the speed downstream would be 210 miles divided by 10 hours, also known as 21 miles per hour. And with these two things, we can write our system of equations. We can write 3 equals x minus y, because my boat speed is being slowed down by the current to reach this speed of 3 miles per hour. And on the way downstream, to reach my 21 miles an hour, I'm taking my boat speed and adding on the speed of the water. So here is my system, and we can now solve this system to find out what x and y are, to find the speed of my boat in still water, and to find the speed of the river. So pause the video, and I want you to try and solve the system. Some of you may have solved by substitution. I'm going to solve by elimination. Some of you may have eliminated the x's. I'm going to just add the two equations together and eliminate the y's. 2x equals 24. X is 12. And I know that 12 plus y has to equal 21. Subtract 12. Y is equal to 9. And now we have to make sure that we answer the question. So the boat speed is 12 miles per hour, and the river speed, or the speed of the current, is 9 miles per hour. So here's two examples of how we translate these words into mathematics, solve a system, and then answer the questions using the English language again at the end.